Hi everyone, I have a pretty standard limit problem for you, but we will evaluate it in a cool way. So usually when we have power like this thing is equal to n to the 1 over n, we usually take logarithm. It may work. So let's say this is equal to L and take logarithm of both sides. Log L is equal to log of this thing, and we know that logarithm is continuous, so we can swap limits and logarithm. So limit as n goes to infinity, logarithm of this thing is equal to n to the 1 over 1. And now I can use the property of logarithm and take this 1 over n before, so it's going to be log n over n. So now let's see if we can squeeze this thing with the help of squeeze theorem. So we know that anything in absolute value is greater or equal than 0. And now let me introduce you a basic inequality. This is how the logarithm is defined actually. We know that log x is less or equal than x minus 1. This is true for all x greater than 0. And we can also simplify this by saying this is less than x, x minus 1 is less than x. So now, if I use the inequality right now, it's not going to be useful because I will have n over n, which is equal to 1, and it's not going to be helpful for squeeze theorem. But if I multiply and divide this by a number, it can be any number actually, log n over n. And now, if I take this two to the power, it's going to be n squared, and it will be less than n, which is not going to be helpful. It will be infinity. But if we take this two, so I'm separating this two here, and I'm throwing this 1 over 2 to the power, so it's log n to the 1 over 2 divided by n. And now I can use the inequality, and this is going to be less than 2 times n to the 1 over 2 divided by n, which is equal to 2 times 1 over n to the 1 over 2. And this is just square root. It will again go to 0. So now we know that log L converges to 0. So we can just take this I here. So L will be equal to e to the 0, which is equal to 1. And this is our answer.